Well, welcome to 9.2 homework part 3. You may have skipped here for just to look at an individual problem, but if you're looking at this, you might want to look at the part 1, part 2, but you most definitely would want to have looked at the notes by now, because I'm going to assume you have some idea of the basics of this. So here we go. Find the standard form of the equation of the ellipse. I want x squareds, I want y squareds. And if I can get those things, or quantities squared, like x minus 2 quantity squared, I like that, but I need this to be 1. Therefore, I need to divide both sides by 36, and I get x squared on 36 plus y squared on 9 on 36 is 1 on 4 equals 1. So we're always driven by making that right side become 1. And at that stage, I know what the graph of this looks like. We're supposed to find the standard form, got it, find the center. Center is 0, 0, my vox, my voy. There is no right, left shift or up, down shift. Find the vertices. Well, let's sketch it first. We've got to sketch it anyway. So center 0, 0. I need to be able to go right and left 6, up and down 4. So let's just do this. Right and left 6, up and down 4. They look like this. And I've drawn better ellipses, but I've certainly drawn worse than that. Okay, so we've got that just from the center being 0, 0. We move to the right 6, left 6, up 2, down 2. So our vertices are at 6, 0 and negative 6, 0, plus or minus 6, 0. The foci, a squared equals b squared plus c squared. C is square root of 36 minus 4, 32, or 4 square root of 2. So I don't know, 4 square root of 2 is about 1.4 times 4. It's getting close to 5. They're somewhere in here, but we'll name them correctly. The foci are to the right and left of 0, 0, 4 square root of 2. So that's plus or minus, try that again, plus or minus 4 square root of 2 and up 0. And let's see, eccentricity is C on A. So the eccentricity is 4 square root of 2 on A is 6, so that's 2 square root of 2 on 3. And we got it sketched, and we're not going to graph it. So there we go. Now this problem, not too bad. A little bigger numbers here, maybe calculator worthy. But I'm going to go 49x squared plus 4y squared equals 196, and now I want that to be 1. And otherwise it's just like problem 35, just bigger numbers. So I'm going to divide by 196 both sides. And conveniently, 49 divided by 196 is 1/4. So I get x squared on 4. 4 goes into 196 49 times. Y squared on 49 equals 1, and we're in business. So the center is at 0, 0. And we're going to go up and down 7. I'll put it here to preserve some room. Up and down 7, but only right and left 2. So I'm just going to call this 7, this negative 7. We'll call this 2. Alrighty, and then we have the vertices. Therefore, we don't go to the right and left to get to the vertices. They're at 0, but we do go up and down 7. The foci, let's see, a squared 49 equals b squared plus c squared. C equals square root of 45 equals 3 square root of 5. And wherever that is, somewhere around in here and here, but we'll name them correctly. The foci, to get there, we don't go right or left. We do go up or down 3 square root of 5. And the eccentricity is C on A. And that is it. But now they let us have it a little bit from this point forward, because now we have to get the square completed on x and y, and you're going to see 39 is pretty convenient, but they don't necessarily have to be, as we're about to find out. So here we go. I need to get the x's squared, so I'm going to group these terms, and I'm going to factor out a 9, and here's an important emphasis. I'm not factoring out 9 because I can. I'm factoring out 9 because I have to. So I'm going to factor out 9. I get x squared plus 4x. I'm going to leave a blank. Some of you probably recognize why I'm going to do that. Others, you'll come along. Plus the y's, I'm factoring out a 4 because I have to. It's all about this term. If this was 7y, I would factor out a 4. So 4 times y squared minus 6y, leave a blank, equals negative 36. And now back to day 1 in here at the beginning of the year. You and a fellow student paired up and taught each other how to complete the square. We take half of 4, 2, square it, 2 squared 4, put plus 4 here, but that was not part of this equation. We take half of 6, 3, square it, 9, plus 9 here, that was not part of the equation. When I put this plus 4 in, these were no longer equal. I actually added 36 to this side. When I put this plus 9 here, I added an additional 36 to this side. So I need to add those to the other side, and now I get 9 times x plus 2 squared plus 4 times y minus 3 squared, negative 36 plus 36, 0, plus 36, 36. And now I'm at a stage where I was on, it's messier, on 35 and 37, where if you're not careful here and just look at this step and don't listen, you'll think, well, 9 and 4, least common denominator, divide 36. But I'm not driven by that at all. I have to make this be 1 now. Divide 36. Divide 36. 9 on 36, 1 on 4. So I've got x plus 2 squared on 4 plus 4 on 36, 1 on 9. Y minus 3 squared on 9 equals 1. Oh, now it looks like that's kind of what we're looking for. So our center, MIVOX, most interesting value of x, negative 2, most interesting value of y, MIVOY is 3. And from there I'm going to go up and down 3, right and left 2. So I mostly need to be left and up. Okay. So I'm going to build a graph over here. Let's see, negative 2, 3. Going to regret that. From there, I go right and left 2. I go up and down 3, and there's my little bit of regret. My ellipse looks like this. That's bad. And this. So I've got our center at negative 2, 3. The vertices are not here and here. They're on the long part. So that is negative 2, 0, and 1, 2, 3, 4, 5, 6. Negative 2, 6. So I've got the center, I've got the vertices, the foci. Well, here we go. A squared equals B squared plus C squared. C is square root of 5. Square root of 5 about a little more than 2. So my foci are up and down a little more than 2. So the foci are located at, they're still left 2. To get here, I didn't really come left and go up there. I came left, went up to here, and back down. I went to the center, negative 2, 3, and then from 3 I went up and down square root of 5. And finally, the eccentricity is C on A being 3. Alright, whole lot going on there. My screen keeps timing out. Again, I don't know if that affects the video, but I'll try to be alert to that. Okay, now you're going to see not quite as convenient. Group my x's, factor out a 6 because I have to. X squared plus 3x, leave a blank. Factor out a 2 from the y's because I have to. Y squared minus 5y equals, leave a blank, negative 2. And to be perfectly honest, in this section and the next section, and some even in 9.1, the completing the squares, this step in here is it's not even close, is by far where people make the most mistakes. And usually we're balancing to balance the equation. Okay, I need to take half of 3, that's 3 halves, I need to square it, 9/4, and put it right here. I like to underline it with 2 lines just to remind myself, hey, I just changed the equation. Half of 5, 5 halves squared plus 25/4. I just changed the equation. What did I really just do here? I really just added 9/4 times 6, or 6 and 4 reduced to 3 and 2, 3 times 9, plus 27 halves. What did I really just do here? I just added 2 times 25/4, or 25 halves. Okay, so I've got 6 times x plus 3 halves squared plus 2 times y minus 5 halves squared equals, let's see, that's 52 halves, that's 26 minus 2, 24. Now, if you were driven by the left side, it would be tempting to divide both sides by 6 here. But we're not. We're driven by this side. I want this to become 1. I've never emphasized that as much as I have in past years. All the years I've taught, I've never emphasized this. We have to make this become 1, and hopefully I'm going to eliminate those errors. But a lot went on to get from here to here, and it's going to take some practice and some dedication in checking your answers. So I'm going to divide by 24. Divide by 24. 6 on 24 is 1 on 4. X plus 3 halves squared on 4. 2 on 24 is 1 on 12. Y minus 5 halves squared on 12 equals 1. And so what do I know so far? The center is my vox, negative 3 halves, my voy, 5 halves. And from there, I like to draw it. So a little bit of planning. I'm going to be left a little bit, up a little bit, and I need some room to go up. I'm going to go up square root of 12. So that's, maybe room to go up 4. So I'm going to give myself, we're going to be a little bit more left and a little bit more up. Let's do this. So I'm left 3 halves, up 5 halves, 2, 4, 5 halves. I'm gonna use this as like true stepping by ones. So there's our center, negative 3 halves, 5 halves. From there I'm going to go right and left 2. I'm going to go up and down square root of 12, which is between 3 and 4. So up from here, up 1, 2, 3, and 4, somewhere in here. I don't know if it's certainly not exactly right there on that tick mark, but it's somewhere in there. Down 1, 2, 3, and 4, somewhere around in there. We could always find out what square root of 12 is on our calculator and try to draw it a little more accurately. Okay, so I've got the center. The vertices up here, down there, we start at the center. How did I get to the center? I went left 3 halves. Then I went up 5 halves. From there I went up and down square root of 12. Square root of 12 to square root of 3. Okay. Foci. I know that a squared equals b squared plus c squared. C squared equals 8. C equals square root of 8 or 2 square root of 2. Therefore, the foci, let's see, square root of 8, almost 3. Up 1, 2, 3. We're right in here. Down 1, 2, 3. We're right in here. So the foci, to get to those, I went left 3 halves. I went up 5 halves. And from there, I went up and down 2 square root of 2. And eccentricity is C on A. The square root of 12 is 2 square root of 3, so I get square root of 2 on square root of 3, or of course, square root of 6 on 3. Now, if you just watch this problem, there is a lot going on, admittedly. But this is honors level math. You should be able to do this. If you're waiting on 43, pause this video, go through the problem, see how you do with it. There's a lot going on there. You've seen notes on this, you've seen an example, so we need to put on our big boy and girl pants here, give this one a shot. Okay, I'm going to group my x's. I'm going to factor out a 12 because I have to. 12 times x squared minus x, leave a blank. Group my y's, factor out a 20 because I have to. 20 times y squared plus 2y, leave a blank, equals, add 37 to the other side. Same equation, just rearranged, but the equation is going to change. Half of negative 1, that's negative 1/2 squared plus 1/4, but I changed the equation. Half of 2, 1. 1 squared, 1. I changed the equation. I really added 3 to the left, so I'll add 3 to the right. I really added 20 to the left, so I'll add 20 to the right, and I get 12 times x minus 1/2 squared plus 20 times y plus 1 squared equals 40 plus 20, 60. And I'm going to divide both sides by 60. You might like to just say, well, let's just divide every term by 60. But that, in effect, is the same thing as just dividing the whole side. But it might be easier for you to see. I get x minus 1/2 squared on 5 plus y plus 1 squared on 3 equals 1. We have a center. my box, my boy. And from there, I'm only going to move to the right a little bit, square root of 5, a little bit more than 2, and up and down, square root of 3, a little bit less than 3. So I'm going to use true scale here, 1/2 -1, and I need to go up and down a little bit and right and left just a little bit. So let's go. Might be more than I need. 1/2 -1 center. From there, I go to the right, square root of 5, a little bit more than 2. That'll be 1, 2, a little bit more than 2, somewhere in here. Right and left, 1. A little bit more than 2. Up and down, square root of 5, a little bit less than 2. Up and down, a little bit more than 2. Up 1, 2, a little bit more than 2. Up, down, 1, 2, a little bit more than 2. Now this is looking pretty darn circular. Don't let the graph lie to you. Use the numbers. A little bit more than 2. This actually should be a little bit less than 2. Sorry, my up and down. I'm not going to redo this video. I was looking at the square root of 5 again. My y is up square root of 3. So this is a better representation of the graph. It actually was circular the way I was doing it. Okay, so there's our graph. So here's our vertices here and here. So to get to the vertices, I went to the left 1/2, but then I went left again, square root of 5, plus or minus square root of 5, right and left. I went to the right 1/2, excuse me, right and left, square root of 5. And then I stayed down 1. For the foci, a squared 5 equals b squared 3 plus c squared. C equals square root of 2. Square root of 2 is up about 1.4. Nope. Right and left 1.4. Right and left 1.4-ish, something like that. So there's our foci. More importantly, to label them, how did I get to them? I went left 1/2, I went right and left square root of 2, and I stayed down 1. And eccentricity C on A times square root of 5 on square root of 5 for square root of 10 on 5. And there you have it. Hope that went well. There's a lot of opportunity to make little mistakes there. Stay well. Part 4 will be coming up.